Okay, good afternoon. So welcome you all for the last week of discussion of this year's monsoon. And all of you know that we are not going to have a drought this year, and we are heading for 6% below normal, which is exactly what IMD predicted at the lower end of the prediction. So it's very interesting. When we started this discussion in 2015, I would have made the correct prediction for a drought, 2015. This year, they made the correct prediction for not being a drought. So both in between, they are not that correct. So the two ends of this discussion, they were right. Well, let's try to understand something about how it happened. Now, first thing I want to point out is I had mentioned that if the El Nino continues to be strong, it is strong, and anomaly around 0.5, 3.4, we should be here. But we are on the side. Okay. And of course, everybody will say good IOD, but the real mechanism is still not very clear. So September, for the first time, is coming on the what we call the wrong quadrant. Okay. Most of them are lying on this line. A few of them are like this is one of them, which September is above normal. And if you go back and see around September is around 15% above normal, okay, which is pretty high. Now let's look at the all India distribution. What's interesting is we of course had a bad monsoon here, but most of because this is just September, not all India, not the whole, but just September alone. Most of the rainfall occurred in the region, in Gujarat and I think Andhra Pradesh. There were low rainfall events in Uttar Pradesh, of course, in Karnataka. Kerala was a little bit, but overall Kerala very bad this year. We'll see that later. Now, this is the picture for subdivision. One other one is district wide. This is the whole season till yesterday. And you see that 25 divisions were normal rainfall, 7 divisions of which 2 are here in South India, 5 are here in Indo-Gangetic Plain and Nagaland, Manipur, Meghalaya, and Tripura, and 3 are except West Rajasthan and South Africa. Okay, so I would say that not only we are well within the plus or minus 6%, even the distribution wide is quite good because typically this is what happens. Even in a year well above monsoon rainfall, typical normal monsoon year around 25, 26. So during the normal, a few will be bad, few will be good. So I would even distribution wide it's not bad. Although you will see the place in the East Uttar Pradesh for the last 9 years we have been discussing has been below normal. So that thing we will not figure out why one part of India seems to have a trend of negative anomaly for a long time. Okay, nobody has looked at this. It's a small reason, difficult to explain. Same thing, you can look at district wise. You see more interesting links between various parts of this one. The subdivision sometimes hides the finer scale distribution of rainfall. Okay. Now let's look at the time series. We started in June late because of the cyclone, if you recall, and so June was below normal. But July made up for it with lots of strong events, and then we have this spectacular decline in August, long break, minor revival, but again it went back. So this was the longest break ever in August so far in our 150 years. That is IMD, we never see such a long break. But because of the recovery in September, 15% above normal, we are not going to have a drought. So this is a very peculiar, interesting feature. And what I feel is that the obsession in Indian monsoon rainfall, what do you call, studies have been only on El Nino, La Nina year, the ENSO years. Okay? There's not much study on the so-called normal year. The so-called normal year is not normal. It's normal because the average is over 4 months. Okay? There is compensation between different months. But I think there is a lot more to learn if you examine the normal more closely. But of course, for the concern, and you divide the normal seasonal mean into 4 months, the division is arbitrary. We are using our calendar, which is June 1st, July 1st, August 1st. The monsoon does not obey that rule. The break may be in between 2 months. So there's a problem there. But still, I think there is a scope to analyze the rainfall evolution during the monsoon season on a smaller time scale and try to understand. There could be a normal rainfall in which all the months are normal. But if you look at the data of 153 years, you'll find there are very few years where all the 4 months were normal. That is plus or minus 20%, which is the rule for small time scale. So most of the other normal years, one was excess, one was deficient. To me, there's a lot more to learn from that information. We want to compare two, suppose you want to compare 2 normal monsoon years, and you do a composite. It's not right, because in 1 year, you'll find that June, July were more normal, August and below normal. Another year reversed. So it's a different evolution, and there is more to learn, but somehow it has not been done. Evolution monsoon. Okay. Now let's compare this. Today, around 810, 828, yeah, that's where they're right now. And in the next 3 days, only 3 days are left. Definitely be around 5 or more. So I put 16. You add these two, you get around 826. Okay. It's exactly 95% of the normal. Okay. So after 2015, we are not at a major drought, so we escaped drought this year. Now that's also remarkable. If you look at the sequence of droughts in the summer monsoon, once every 8 years you do get a drought, approximately. And so we escaped this El Nino drought. Next El Nino will not come next year. We hope so, as far as we know. So we have postponed the time between the 2 droughts, because there are a long spell of La Nina last 3 years. Okay, now just want to show you why this could be one of the reasons. There's only speculation. I've not done detailed study. We do a decadal mean rainfall starting from 1844 onwards. Okay, you find that in 1830 had the highest decadal amount of rainfall, close to 900. Then went down, and it fluctuated, went through a period of low values here, and then it picked up in this period. As a matter of fact, this is very interesting period because Gilbert Walker proposed southern oscillation around this time, and his statistical method was developed. Okay, that's why IMD still likes the method a lot. After he made the method public and so on, it was used. The next 30 years, monsoon was above normal. Okay, and so there are very few El Ninos and there are very few droughts, and that's why when Walker died in the 50s, in his obituary, it was mentioned that his statistical method connecting southern oscillation to monsoon did not work. But that's just bad luck. That happened to be a few decades, I think, above normal. Then again, we had pretty good rainfall around the, then it came down. Okay, we had lots of problems. We all, many of us were in schools at the time. We had many droughts together. Okay. Then it went on further. It went on further, and the lowest was the first decade of the 20th century. Okay. Now it has recovered, and recovered dramatically. So this is not, I just put it that you should look at it for 3 years. 3 years is not a decadal average. So we'll have to watch for the next 7 years and see what happens. But there are all indications that this is going to go up because of the well-known decadal variation of monsoon. So this is from Dr. Rajivan's presentation. It shows that if you do the averaging of the high summer over a large period, you will get this kind of cycle. Okay. But the warning is, there's approximately 60 years, not exactly 60 years. There's not a clockwork. The Indian monsoon is a highly nonlinear system. Like the MJO, there's a huge range of scales. So it can be 40, it can be 50, it can be 60. So what happened was, and this was predicted, everyone said, let me just start an easy one here. 1840 is the minimum, 1960 is the minimum, and then 2020 is the minimum. That's how they argue. But it didn't quite come out that way because the periods are not exact. They fluctuate. So I think we have reached the minimum here, in my opinion. Okay, and we are going to start going up. We reach minimum somewhere here. I think we'll start going up now. This is just natural variability. I'm not talking about anything else. On top of that, that is global warming. So these two combination, I think you will see, let us see what happens next decade. You will see that many of the so-called El Nino droughts will not be droughts, but will like this year, will just manage to escape it because of large-scale variability. Now, of course, we don't know how the factors influence the decade variation, that is Atlantic vertical oscillation, Pacific decade oscillation, all these are changes are there. So they may also change the global warming, we don't know. But if they don't change too much, then you're going to have a recovery from this one on, looks like. Okay. Now, there's an interesting paper by Joseph, published 10 years ago, in which he connects the decade variability to the north-south contrast in temperature, okay, between northern hemisphere and southern hemisphere. Okay. That also shows the decade variation. Now, that's also interesting because all of you know, due to global warming, northern hemisphere is warming more than southern hemisphere because northern hemisphere is land mostly, southern hemisphere is mostly ocean. Ocean lags behind in the warming. So this contrast is already there, I'm sure. Someone should plot it. I'm sure it'll come out. So this is additional complication due to climate change on top of natural decade variation. As far as I remember, 50 years ago, most of the work done by IMD scientists was on the connection between sunspots and decade variation. Because sunspot is a 11-year cycle. But turns out not that clean, that thing. But if you do the analysis of this time series of 150 years, you see a 60-year cycle, approximately, not exactly. Okay. But the cause is not clear. Okay, now what's going to happen in the next few days, according to the forecast, it will be above normal well beyond September. So some of you mentioned this, that September 30th is the artificial date where this monsoon is over. It's not over. It continues on. And this year is quite possible October rainfall may go normal. That's quite possible. As a matter of fact, we discussed this issue a few weeks ago. Actually, there are people who have been advocating what they call hydrological onset, not the onset may be only based on whatever flux. Okay, there's a paper with Monsoon, I'll mention people later. So in which he says all over the world, you can define onset and demise of rainfall where there is a seasonal cycle, just based on whatever flux. In a way that Arindam uses in his paper, take integral of water vapor into and the velocity and that flux. When it crosses some value, the onset occurs. Okay, so that is a better choice. If you do that, this year maybe the withdrawal may come a little later. Okay, I'll show that a little later. Now let's go back into history. So IMD likes the forecasting because it was started by Walker more than 100 years ago, and it also found the numerical model with 18 parameters, which is statistically not acceptable, but it is very popular. 18 parameters fitted to some 50 data set. They got almost right results. That the forecast is right, and actually black here or green. And you can see they failed in 1994, which all of them had IOD, but then they were reasonably good. Then came the spectacular failure in 2002. They said it happened to be one of the most severe droughts. That's when IMD woke up, threw away their Gaussian model and adopted a different circle model and also got into dynamic forecasting. Okay. Let's see how we have done after 2002. Yeah, so this one from this paper, I forget which one, which compared the period between 2001 and 2016. IMD forecast is here and actually is here. Well, the reason I saw this figure is this figure is very nice to show that anytime you make a prediction in statistical forecasting or ensemble mean time forecasting, you cannot get extremes right. Extremes are special. If you take 50 run about with 50 initial condition and average it, you'll miss extremes. So you can clearly the model cannot correctly get the extremes because of the very nature of your scheme. You use a statistical method, it will get you the mean correctly. You use a dynamic method with And the sample mean, we'll get the mean correct, but not the exchange. Okay, so let's say how they did the past 10 years. So here what I'm showing is IMD separately talks about principal bond and what which is good, because I would say neither is good at this point. So it's better to look at both. So that's yeah. Yeah.
Normally that sounded B,
Uh-huh.
but they have the whole set of examination. So, yeah. So there's the opportunity possible thing that and a lot of we have to also go there.
Yeah. Years back, I think that who runs the theater store in CMAX, he showed the resolution. Variability is pretty large. Yeah.
Yeah, so then it's okay.
That's okay. That's it. But given here, you trust the extreme result on the means of the relation.
Yeah, that's right. But I mean, this
Absolutely, there's no question that is there. But which one you want to choose to make a forecast?
that is difficult.
Almost all the business is there, except maybe some cloud visit, everything is there, we know that. But extreme events are tricky because it goes various complicated things. So I would like to see how, that's why I think what we have built out in India is trying to do it now more than 15 years of them forecasting it, a detailed discussion on each of the members.
Yeah.
I mean, audience is like, we don't get the data, you put the data on the website, like DNA, let the students analyze each experiment figure out among the 50 output in which then have to confidence. Normal output is mean, but based on the performance model for the last 20 years, can we guess which particular condition is a better forecast? That has not been done. So that is one of the, for example, how did I be correctly arrive at a forecast 2050 and this year? We don't know. There is no discussion. But in 2015, I can tell you. In 2015, I'll come to this. In 2015, you can see clearly that the reason why they were so confident was both statistical and dynamical. That it is well below normal. And so they were confident. Okay. Next year also, both of them said it is above normal, but they were wrong. Okay. So there was overconfidence after that. But it is true that if both two independent methods correctly predict, you do that. Now I believe Ravi is not here, but Ravi gave his machine learning forecast IMD. So this year, I don't know what statistical model gave, but it's quite possible that statistical model, Dan model, and machine learning all gave around 95%. So they have confidence in it. So I would say, one number of methods you use, the chances are you won't go wrong that easily. Okay. So you can see that in this period they're not bad, except there were failures in 2019 when we had unusually high September rainfall. Okay. 2020 was not bad, but not yeah, dynamical big better, September not so great. So things are improving here, but still we have a long way to go. Okay. Because statistical model demands a lot of data, we don't have it. Dynamical model still a long way to go to get the Indian market correctly. And machine learning, I don't know how it's about it. Machine learning has done quite well, but again, the comparison that people make, you can see the large number of papers for the last 10 years on machine learning, okay? For the Indian market, large number of papers. Some of them are useful, some of them are okay. And the trouble is, because machine learning demands a lot of data, they use, let's say they use 130 years or 50 years data. They'll use more than 130 for training. And they're testing in a very short period. And from there, you cannot be confident. Because your testing period has to be long enough to have every mode of variation. If you take only 10 years, you're lucky you get it done. For example, I can tell you well-known method. So the Iyengar was a processor. There was a very interesting method based only on past rainfall. He ignored any data on temperature, pressure, nothing. He said, give me the past rainfall, I'll get it. So I was very intrigued by it. How can you use only past rainfall? But you are right for 8 years, 9 years, then failed. Okay. And that it feels very interesting. If you look at his model using interesting mode function, he resolved the time series into various modes. And the problem is the highest power is in the mode of 2.5 years, so-called quasi-Bell oscillation. And that is highly nonlinear. So you use a neural network to forecast, that is not easy unless you have very good long time series. But it's a very interesting method. It involves no physics. It says past data will predict the future. But for 8 years, you got it right. Okay, now look at this year's prediction. It was, of course, that it's been 100%, so therefore all of right. And here also must you very look at carefully. You look at this tercile prediction. There is 33% between this and this, 33% above 104, 33% above 104. Okay, that's what both European and others do it. Three. Now the climatology get 33. They gave the same thing at 35. Okay, but what difference you must notice is they said 51% is being below normal and only 14% above normal. So they took it about El Nino. El Nino was accounted for. So they shifted the distribution to the lower end. Okay, but the mean they said somewhere here and they were right. But that's partly to be a matter of luck because you already said 50% chance that this will be a drought below 95. But you still gave the value as 94 as a matter of judgment. And that's why I want to know what is the discussion in that room in May of 2023, which anyway they decided to put a number like 94. It will be good to have that. Then they slightly modified it in the this around March, May, slightly adjusted it. They increased this quantity. This is 45, this is 43, this is 12. So they were right in not doing this. You all know that. One thing we are sure about after all these years of work is that in an El Nino year you will not get a flood. In a La Nina year you won't get a drought. That is 100% sure. Because both are zero in the last 50 years. The only problem is trying to find out how much above, how much below normal it is. So they still gave 11% here, but they knew to not. Okay, now let's look at spatial pattern. I don't think they have done well. This is seasonal mean forecast in the month of May. This is actual till yesterday. It won't change much. And you can see that their prediction was Gujarat, Maharashtra, and this region will be the contiguous drought. It's not true. Okay. This part they are not getting it right. And most worrying part is Kerala. Kerala had a very serious drought this year. Not just this year. You look at last 10 years data, Kerala is done now. And we have already paper showing that this is global warming. Okay. Global warming should get upward. And Kerala's main range is and so it will suffer. Okay. So this part not being right should worry them because this is a trend which is going on for the last 10 to 20 years. Okay. And this also they're not getting it. There's no signal there. This also they're not getting it. So spatial pattern all wrong. So it means it's one of the long way to go before they make correct forecast at a different level. Okay. Now I'm saying this because climate change has become a big racket in this country. There are NGOs publishing forecasts of rainfall in Karnataka in every district in the next 10 years, 20 years, 30 years. It's absolute junk. Okay. So when I told one of them, they got very upset because they get money to produce these documents. And every state has a document. You can go to every state in India, they have a document about climate change in the next 100 years, every district. And they're predicting about next 10 years. Not possible. The moral quality is not that good. Secondly, all these guys are running double CO2 simulations, which is irrelevant at the district level. At the district level, what we control the rainfall is what is happening in the district with respect to land use, urbanization, and other local issues, aerosol, not CO2. CO2 is very important for a global scale. As it comes to a smaller scale, it's all local factors. None of them all take care of it. But still, they're putting out documents, and people in policy level are quite satisfied. But if you compare with what happened actually, there will be no comparison. Top. Okay. Now, this is the forecast made by Ravi and given to IMD. So he also got the right answer. So the point is this year, everyone got it right. Machine learning, statistical, dynamical, as well as climate, who normally competes with IMD, all got it right. So we don't know whether it's how good the model is. So let's now do what we do every year. We compare the forecast of climate, which is here, Now IMD here, monthly, seasonal and monthly. I can see that at the seasonal level, climate IMD with the same forecast for the first time, and it came out right. But if you look at specific months, this is not bad. It isn't error mark. From here onward, both are wrong. This is well above their range of errors. This is shocking. Nobody got it right. Of course, this is an unusual event, and this also is wrong. So the only luck for all of them is that there was compensation here and here over this, and finally got it right. So this is the situation with for currency in the whole India. But if you look at the special section, you'll see none of them got it right. And now let's look at spatial pattern each month. This is the month of June. Sorry, this is the month of July. June, they don't make a forecast. So July, I would say that partly right. This one, this is comparing well. This is some signals there, but not much. Northeast, little bit, but not much. So July, I would say they got the spatial pattern partly right. Okay. But let's look at August. August also, I would argue they are not bad. The east-west asymmetry is reproduced. The fact that the rainfall is moved to the right is needed, and this is the part of the signal of El Nino. El Nino here, the rainfall system moves a little bit to the right. If you're in Bangladesh, El Nino will always be a flood, normally. Now let's see September. September, I think they got it completely wrong. September, they're putting drought to Gujarat and Maharashtra, and not much signal in North America, but reality is terrible. And this is the region that got the highest rainfall this month. And so the forecast of September also was not that good. And of course, the rain they gave us didn't come on, right? Came along outside the region. Okay, let's order the NQM, that is NQW forecast. May, June, July, August, I don't know there or not. So June is partly right. July is not right at all. July did not have nominal rainfall. And this was, sorry, I didn't know the August one. And this was the prediction made by American models. Been from North America. And I would say they also didn't quite get it right. They only got most of the getting that. But this pattern, I think they got it wrong. I think this year we'll watch the overall thing. The pattern that East Asia got more rain than India because of the shift in the system to the east. I think they got that right. Now let's look at Suman Nigam's forecast. As a matter of fact, at the end of August, Suman Nigam put out a press release saying that I got it right. But unfortunately, September spoiled it. Okay. His forecast for India was 89% below normal. So he's the only guy who got it wrong. Although till August end, he was right. No question about that. But September just completely changed the thing. So his forecast for June to September is a bit too high. But he got Kerala correction. But remember, his forecast is interesting. The thesis of one of his students is not yet published, and it's based only on SST. Okay, it's not a dynamic board forecast. He takes SST all over the world, and the assumption is SST carries the fingerprint of future rainfall. Okay, now they're somewhat similar to what Iyengar did with the time series, but this is spatial. I think there is some merit in it. I think there is something there which is not fully explored. We have been focusing on El Nino and IOD and look at PDO, but there are many other places in the world where the anomaly of SST may affect Indian monsoon. Okay, but only thing is the paper not fully published. I don't know exactly how the system works, but all India he got it wrong. But this party got it right. This portion. Although this is different, that is China and should below normal. Now this year's September rainfall was definitely related to this cooling of the east coast of Indian Ocean, okay, which 24th was pretty strong. 20 is cooling. But I'm still not convinced about the mechanism. Okay? Because as I told last time, repeated, I have no problem with high temperature in the western, in the Arabian Sea, increasing rainfall, because it brings in more material. That's very simple. Okay? Because no thinking. But how will this low temperature equatorial region affect the Indian monsoon has not been explained by anyone. Okay? There's only one thing which favors Arindam's thinking. Arindam does a budget for moisture over India, and he says if a lot of moisture comes in here and less moisture goes out, then we have a good rainfall. Okay? But I can show that this kind of cooling here, which is related to drought over Indonesia, actually causes this flux to decrease. Okay. So there is some evidence that Fe flux on this side has control. This is also much more than as much as this. So this has paper border, and butterfly to the paper. I think it was Strauss paper again, in which it showed that if there is a drought in Indonesia, is tantamount to having more relative cooling because there's a late heating. So for the cools, so it's a negative heat source. So Strauss puts a negative heat source over Indonesia and shows that it affects the flux here in this region. Okay? So the purely Gill model response. So there is some mechanism there. Now this year, the first let's look at the last major El Nino, which happened in 97 and 98. You can see that this is blue is sorry, x-axis is 3.4, y-axis is IOD. Okay, it's not a time series. This is standard plot. So the reason why I showed this is note that as the 3.4 crosses 1 degree, immediately IOD responds. Okay? It's remarkable. So IOD in 97 and this year was slave to 3.4. And I don't know how many of you have read the debates after the discovery of IOD. There were violent debates in the literature about whether IOD is independent of 3.4 or dependent. Okay? And it went on. People use very strong language. Ultimately, Philander, he's a great guy. He got a very nice piece. What he got, it can happen both ways. There are years where IOD is slave to 3.4. There are years they're not. So this year happens to be like 97. I'll show you that IOD started going up only after 3.4 crossed 1 degree. Okay? That's a threshold behavior. We don't know why. So this is the one was this year. This is 3.4. This is IOD, and it's fluctuating between plus or minus 0.2, 0.3. Then around it was one around the I think first week of July, apparently. It just shoots up. This is not dramatic. Okay? So clearly triggered by what happened in the Pacific Ocean. So you cannot treat IOD as independent in many years. It is driven by what's happening in the Pacific. Okay, now the interesting thing about this year September is the unusual pattern of water vapor anomaly. Okay, whole of the northern part of the equator, it's all positive. Southern part is negative. Now, this portion can partly be related to cooling here, but I don't know why here. It's centered around 12 south. Okay. So this pattern is very interesting. And I saw the same pattern in 2019, which had a very heavy rain of September. So there's something to look at the north-south contrasted water vapor change. Yeah, this is 2019, very similar, okay? Not identical, quite similar. So this year September and 2019 have a connection, and since well above normal rainfall number in a 4-year gap, there's something new happening which has not happened earlier. But in 2019, September heavy rainfall, no one got it right. No model. Okay. Yeah. So there is some new phenomenon. We don't know what it is. It is making September rain much more than normal. Okay. Now this is the zonal wind anomaly, and of course this is the one 850 millibar. Yeah. So this is the one which is causing the cooling of the coast of Sumatra, and this is one which throws the uses for defining equine. Equine is the negative of this anomaly. so it's positive. And it causes rainfall to reduce. So, so this is brought out well for the first 20 days of September, the zonal wind contrast. Now, the problem I have, of course, in terms of correlation, I looked at the correlation in Indian monsoon rainfall with winds, zonal wind over in this region. The highest correlation obviously is the Somali Jet. So that means the water vapor. That's not a surprise. Okay? Notice wave Bengal is not anything. It is the Arabian Sea because it is looking this way. Notice that around this region where equal is defined, the correlation is very low. Now I'm showing you this to argue that correlation is not a good way to understand phenomena in a nonlinear system. You are using a linear correlation. Linear correlation is not a good metric when a system is nonlinear. Okay, so this will tell you that it's not important, but really in certain years it's very important, like this year and 97 and other years. So one has to think of, there are metrics available, but I'm not an expert at it. There are nonlinear ways to, if you know the system is nonlinear, and if you know the shape of nonlinearity, then you can come with different correlation metrics other than linear correlation. Okay? Remember that. So there are methods available now with a lot more techniques. Somebody may be able to use a different metric to point out how intermonsoon rainfall and the wind in the equator are connected. The linear is not good. Now again, I want to show you this link between Indian monsoon rainfall and SST over this region. There is almost no correlation. There's correlation here, obviously, because this is because as the Indian rainfall increases, Somali Jet speeds up, this cools Arabian. This is almost gone. So there's not Arabian Sea causing Indian monsoon rainfall, other way around. Indian monsoon cooling the Arabian Sea. Okay, but this one is very surprising. Along the equator is almost no correlation. So again, showing you the correlation is not a good metric to understand the dependence of one variable on another. Yes. Do you have questions, Rosana?
No.
Okay. Yeah. Now let me summarize. I showed this compilation done by Rupa Kumar 20 years ago. I updated that to this year. Okay. And I use the current IMD definition of mean value 870. 870 minus 10%, 870 plus 10%. So, this is below normal, but not a drought. This is above normal, not a flood. This is flood, this is a drought. Okay. Now, we're telling you that of the total number of El Nino years in the 1 to 3 years of data we have, 50% of the years are El Nino years, and other 12 are not droughts. Only half the El Nino years are drought. Other half are below normal, but not drought. And more are actually within that below normal, but not a drought. This is slightly above normal, but not a flood. Okay. Look at La Nina, same thing. No drought, mostly above normal, and floods. Okay. So this is the character of these two. But my point is that there will be too much focus on these two because they only constitute 54 years. Okay. Only 1/3 of the years. Most of it is here. 99 years are neither El Nino nor La Nina. Okay. And out of that, 75 years are the so-called normal range. But the fact is, if you look at those 75 years, they achieve normalcy not because every month was normal. If there are ups and downs, then they got cancelled out. And there is signal there is worth exploring. May not be easy, worth exploring. And of course, people cannot explain the 11 years of drought, 13 years of floods that occur in a non-El Nino, non-La Nina year. So to me, this will require further investigation. Now, I'll just quickly go through the success of the short-term forecasting of this year, 10-day forecast, which I've been showing you. They got the initial late onset correctly. And then it started increasing in June later part of June, they got it correctly. Okay, so both those were good. And then, most important, the end of June, the sudden increase in the monsoon activity, and that was correctly got to within a day. So to me, that's a good success. They said 26th June will jump up, it jumped to 26th June. They made the forecast 1 week in advance. So to me, clear evidence of very good short-term forecasting happening. And so this should be helpful. But the question is how to extend it for a long period. So they got it right. They jump as well as it gave roughly constant. Yeah, and this one is also by around July 31st, they predicted that around August 3rd it will decline. There is a slight error here, but otherwise they got correct. So they got the meaning of the break correctly. So that to me is again great achievement. And now let's look at some of the regional. We already look at all India, but it's important also to look at regional. So two subdivisions of not subdivision, even smaller region. Okay, yeah, these are subdivisions, sorry. So each of Uttar Pradesh and South in Karnataka are two subdivisions which had very bad year this year. The only year only 3 weeks below normal, 2 weeks normal, rather than all normal. Okay. And this is happening for many years in Uttar Pradesh. And here, North India Karnataka, which we are part of it, you can see that the one good rainfall week, which was 20th July, that's it. And a little bit in September beginning, all of them now. So the Kaveri dispute is to do this unfortunate thing that's happening. But still, we are not as badly off as Kerala. Kerala is the most shocking that they were 39% below normal. Okay, not 39%, and they had only few weeks of normal rain, but now they are improving. I think next few weeks they may get more rainfall. And so, question is, can this put have predicted in advance? So that is, I think, should be to me. Kerala rain is very orographic. If they get the wind direction right, they should get it right. But I've not seen any discussion, or not a single paper, which asks how good are the models in predicting the wind direction. I'm not seeing it. I don't know why. The possibility could be that during the monsoon season, the zone will be so strong that a small change in wind direction will change the direction very slightly. And maybe people don't trust the tangent you have to take between middle and solar wind will give the angle. Okay, but that angle is very critical. You'll see that in Kerala also, not all parts of Kerala are getting low rainfall. Because of which angle the wind comes, some of the mountains are oriented such that that angle is suitable to them. Okay, it's more complicated. Now, I like to show this comes regularly in the IMD website. This is weekly cumulative process on monsoon, and you can see that with a late onset, so that's below normal. Then slightly recovered in July, but we didn't fully recover. And you can see here Kerala is by 39, Bihar by 27, and most other parts of Karnataka are negative, and so is Rayalaseema and so on. Okay. Only when you go to Telangana and others, you get positive. Okay, now I want to show you the actual rainfall, station rainfall data from Kerala. You can see last year, this year, out of all that are shown, only 3 stations had normal rainfall. That should be fixed. Should be rain not part of it. So only Alapura and Pathanam, only 2 of them are normal. That also by definition is -15% and 19%. So it's very close to deficit. But this is slightly better. Sorry, last year was slightly better. They had more normal rainfall in distribution. This year was particularly bad. And there's a trend. So I don't know what action the Kerala government is taking, because steadily the rainfall is declining. But for most of us who live in other parts of India, Kerala is such a heavy rainfall. So you might think, okay, I don't know what it doesn't matter. It matters because the ecology of Kerala, for natural ecosystem of forests, birds, and trees, decline rainfall has huge impact on ecology. Human beings may manage by pumping more groundwater and do other things, but nature will have to change. Okay? That's going to happen. Now, just want to point out this hydrological onset is based on this integral due to DP like the kind that Harinam has done with many papers with Pianchi, and then they artificialize it in a shorter way, so that the value lies between -1 and +1, and then it causes 0 the integral onset. The merit of this method by Monsoon and Webster is that it is valid all over the world, not just for India or Kerala. It's universal validity. The only thing I don't like is they get the onset correctly, close to correct value. The withdrawal is 7th September. Now that is very worrying. That is too early. Okay. So I know they're not discussed why. Why it's so early, almost 3 weeks before. So that's the only big point. That's why it's not been widely cited. Although I think it's a very nice piece of work, requires a little more discussion on that. And here they are comparing hydrological onset and withdrawal in 2 years, that is 72 and 75. 72 was the drought year, 72 was the flood year, and you can see they're getting the onset earlier and you're getting there. But still there, even in a flood year, the withdrawal is very early. So this requires some attention. But nobody has looked at it so far, how to improve it. Now, I'm not, but discuss this, but I'm not at time, so today I'll talk about it. To me, if you want to understand the long-term break the 10 days, one has to look at it not from the perspective of phenotype system, but a last year. Okay? So the best way to do it is by studying the budget. Okay? It's my favorite like that, because for a long time, when I entered this field, all the discussion I heard was monsoon was more because there was more latent heating, which is ridiculous. So latent heating is due to monsoon. And you can't say latent heating caused the monsoon, you cannot say that. So there is completely getting the cause and the effect opposite. So I was very unhappy about people arguing the latent heating caused the rainfall. The question is what caused latent heating? So the best way to avoid it, proposed by Bill held more than 35 years ago, in that you take the energy equation and the moisture equation, add. When you add the two equations, latent heating disappears. Well, latent heating is a source in the energy equation and a sink in the moisture equation. Okay? When there is rainfall, you are sucking water vapor out of the air. So when you combine those two, no latent heating is there, okay? Except surface flux. That's okay. Surface flux is not same as latent heating in the atmosphere. So latent flux, surface flux, long wave, short wave, and water is transported. So this is very nice question. And on a weekly and other basis, which are very small and neglected. So in this approach, okay, only problem is because you added two equations and the dominant terms cancelled out, sometimes the budget is not balanced. There are okay, that problem is not yet gone. So you have to remove the most important term, it is the latent term. So the smaller terms play a role, and you are getting residuals when you actually take the data and do the matching here, you find there is some residual. Now it should not come in a realized data model. You should not get residual because of the coupled model is indicated over a long period. And if the model does not have proper marketing budget, it will not reach steady state. I can guarantee that. The fact that model is steady state of 100 is everything is valid. But when you take the data from the model and actually don't why? Because the model is balanced in the coordinate system of the model, which normally is Sigma coordinate system. But the output is given project coordinate. I don't know why. I wish I would use Sigma coordinate itself, but most people don't give you the Sigma coordinate. The project coordinate is compromised. Because this was discussed by Trent more than 30 years ago, that if you take the output from any model or analysis and look at the mass balance, it's not balanced. du dx plus dv divided by dv is not 0. Because they converted the velocity in sigma coordinate to pressure coordinate, and there is an error in that. And that error is very, very important in the mass budget equation. If the mass budget is wrong, everything is wrong. So I hope somebody make a request to ERA and to put out the sigma level data. If some of you know what it is, let me know. We can look at it. I'm sure that there will be no problem. Because we know the real analysis is done correctly. So is the model. They are all balanced. But when you calculate it, you don't get the balance. I'll show you the example. So this is the work of Annamalai, published more than 10 years ago. So here is the peak of the break. Here's our date for the break. Here's our the break. Okay. All the breaks have been compensated. Now I wanted to only focus on two things. One is, unfortunately, the large result of the order 20 watts per square. That worries me. The reason that large, you can't make any estimation. So one has to hope now somebody will do the same thing for ERE5. I expect to be lower. Okay. And if they're lower, then we have to drop it. 10 years back, you are interim, where it's not that good. But still, in part of that, the interesting thing here, look at net radiation, which is the denominator on the equation to predict. Put the slide. So the favorite equation for understanding this one is what for gross mass stability. Okay, this is the equation which to understand this is not a equal prediction with diagnostics. It says rainfall minus evaporation is what is the energy available at the top of the atmosphere by vertical structure of the atmosphere. Okay. Now this will tell you, even on a weekly scale, that if for any reason Qnets are decreasing, rainfall will decrease. Okay. Now you can see here, anomalous both is part of what the problem with the balance. Qnet is decreasing. Qnet is Qnet, I'm sorry, yeah. This line 10 days before the peak of the break starts decreasing. Okay. And the decrease is 30 watts per meter square, which is very large. The Qnet in the month of July is of the order of 40-50 watts per meter square. If you take a 30, from 40 to 30, rainfall will drop by half. If rainfall drops by half, immediately cloud will go down, everything will go down. You are on a feedback process which kills the monsoon. Okay? That's what happens here. So here you're almost having clear sky, the shaker break. Then slowly the system recovers and the Qnet reaches the original value about 20 days later. So to me, this result, in spite of the result, was for the clear role of Qnet triggering the break. Okay? But it requires more work. I would say that not many people will be convinced because of the residue problem. But the other part which is interesting is at the same time we did it, for the same period looked at the equatorial distribution just below India around the equator is exactly opposite. Okay. Here Qnet is this. So in India Qnet went down, the Qnet in equator went down. So there's a clear seesaw between India and equatorial ITC. Okay. So that's a very nice result. So that shows that when break starts happening over India, the ITC gauge equator picks up and the Qnet goes up into the peak at the time the break in India is peak, and then it comes down and becomes negative.
It looks like the active phase.
Huh?
This looks like active phase, not break phase.
Oh, I'm sorry. Oh, yeah, I didn't see that. Active phase. Okay, oh, that's our problem. You're right. Active phase. Yeah, let me explain. Yeah, you're right. Let me explain. There's a peak of the active phase. You're right. In the when break in India, there is active phase. Right. When there's a break in India, the equatorial universe becomes active. So when our Qnet went down, its Qnet went up, and it became more active. Yes, peak of the active universe. I missed the point. So this is a very important result showing the seesaw between equatorial inversion and Indian monsoon. And so the Qnet signal is very good. Others are not that good. Others are very noisy. But this is a very, very nice picture. So one can verify this now with a more recent data set. Now, how about the future? Okay. Now, the forecast of the IRI for next year is that by May, June, July, it will be neutral. Okay. So let me ask, I think the El Nino to neutral next year will be normal, right? That is the prediction. Huh? Yeah. So his prediction is from El Nino to neutral is normal. You may say why believe it, because this year he was wrong, but this year was tough because he had only 9 cases of El Nino. Okay. One case was normal. So now it's okay with this year. But in the case of El Nino neutral, there are lots of cases, like normally about 40 or 50. Yeah. So that is very subjectively more robust. So most next year will be normal. Okay. And so let's hope that is true, because the groundwater issues and so on, we don't want to have 2 consecutive years of below normal rainfall. And this is there in his paper, although this figure I told Narendra take some time to understand. Okay, not even understand the figure. So in this figure, what he has done is he has considered winter conditions here. That is, this year's winter is El Nino. So here, this year's winter El Nino, and you are neutral. You are in this graph. Now this is conflict limit. What is the number here?
The in between.
Huh?
Beta line. Between
No.
That's the blue line.
Yeah.
The middle.
Yeah, I mean, better El Nino this year, and next year is neutral. You get this in the graph, right? Yeah. Right.
Yeah.
Yeah. So the question, what is the number? About 20% is your confidence level, is it?
Yeah.
Not very good. Not very good. Okay, fine. But your confidence level is very slightly below normal is very high.
Yeah.
Like this year.
Right. But
Yeah.
but that is from La Nina to neutral. Beta La Nina.
Oh, not yet. So this is, it's not, yeah. But this is above normal, but you're not very confident already. Yeah, that, you look at all the data, it looks, it's not very clear. Okay, so we'll meet again 5th June 2024. So I thank Sujatra and Taranga, make sure that this year everything went well. So any questions you can ask. Yeah. Huh? Yeah. Yeah.
But I am doing very good on like gradually.
No, 1 year is not anything. That's what the methodology. You take 10-year average. Yeah, 1 year doesn't reduce for time, but not a short event. See, no, that's a very event. You look at Kerala rainfall for last 10 years. Seasonally, something will happen.
Whether it is spatially similar, like, or it is the whatever the extreme events also.
Yeah.
Like, when you actually it chemical like your averaging,
Right.
the regional average, maybe some places might be up and.
Yeah. Yeah. It is very good because on the order plane, I can assure you, even though both the Kerala, you know, and parts of Kerala in certain direction, they may go, yeah, that's possible. That's not it. But the reason why Kerala is not normal is very significant because get the moved out. You can look at data, very clear. That's why the quality of analysis is improving gradually over the last 20 years. But very clearly in again, position is shifted. Then 20 part not a confidence because the data will not get good resolution for I talk for 25 kilometer resolution. You can go back and check that I think not checked it. You should check it, and I think what should check. So but that really me from 0 to 10 off average. What can say anyone specific area? That will be very different. We also see an increase in Karnataka and Maharashtra. So that should be.
Yes, sir.
Yeah.
So you mentioned that the Gangetic delta and not delta, it's the whole Gangetic plain has top line condition for last 9 years. Right?
Yeah.
So that clearly what I can understand from that is the low pressure system tracks are moving southwards.
Could be, but I don't think it show that. See, this kind of thing you should go and check it. The go verify it.
Yeah,
All the data.
yeah, but the actually what I am trying to say, all the same sheets, 5 or 7 sheets, they are saying it will go with the.
You're right, point. If Orissa gets more rainfall.
Yeah.
And more rainfall, and the systems are going.
Yeah, this is clearly.
You're right. But if you look up the witness, there's a Joseph, who has compared because cyclone, the cyclone directional movements for the last 150 years. They're in direction, response to changes in behavior. You're right, exactly. So yes, it means that, but you ask me why did it happen?
Yeah, so I have.
So it's not really nice to confirm the fact that it's not because those systems did not go around their path. But if you ask why it happened, you don't know.
Yeah, all the projects I have seen paper by Ramaswamy and others, they are saying all that the number of low pressure system will decrease, but the trend will go northward with warming scenario.
But why? To be,
But the happening, what's happening is the opposite.
those of the PhD, those are standard by what, our main interest is why.
Yeah.
That's why I put all our effort on, because we can't explain why, then we are not doing anything useful to this.
And I just had another comment that I have checked actually in ERA 5.
Ah.
So I have not done the NST kind of thing, I have done the moisture, just specific to it.
Ah.
So for moisture over sun, it's quite good. I mean, the residual is not less than, not more than 5% or so.
Okay.
But over land, it's still a bit higher.
Yeah, land is important. The land actually, where the regular rain, I would like to know how we are here. Yeah, land is very, Western Ghats, Himalayas, that is a nightmare. Ocean is where you start. That is a clean, flat surface, everything is fine. As soon as we have a mountain, it's going to calculate.
But still, when you compare it to the NK printer and those things, it's quite good.
Yeah, I mean, for Western Ghats, if you calculate U, DQ, DX, you should not allow vapor to come in between surface and 1 kilometer of the mountain. You should allow it.
Yeah.
But with the resolution of water of even 25 kilometers not bad, I don't know whether photography is that. You may not take all the mountain correction. Right. So what can the problem is for that? And that's the indication of example. There is no reliable data of all India Indonesian rainfall. Very hard. It's all over.
But one of the interesting thing might be, we have seen that most of the cases for the northern progressing systems, the most of the moisturizing happens not below 850 boundary layer, but it happens at the free troposphere, 700 to 850.
Yeah.
So there it might be, we might be less problematic because land effect gets lower there.
Yeah, that's possible.
Yeah.
Okay.
So,
Yeah.
that's one of the point from water and the right? So what he was talking about was NPS, right? But what I'm seeing is there is emerging dichotomy between what we're getting from observation and what we're getting from CMM.
Yeah.
Right. So,
Well, typically on module. Typically, even all the models, multi-model, certain models.
so there is a spread, of course, but
Because many models, can happen, right? So you should look at it. One thing you do is, 44 models, throw out those who are not getting right, only keep those who got around 70 meter per day.
right.
So to me, if your B answer is wrong, your modification will be completely wrong. As one is well known paper division published 30 years ago, showing that global warming discussion, if your mean debate is wrong, mean debate was wrong, it makes all wrong predictions in the future.
Right. So, but so things that I'm talking about have been looked at for the past 20 years over many generations across multiple generations of cement and over. So Manabe had this paper with Max in '96, and he saw similar stuff way back then, and these things are being reproduced consistently in several generations of cement. So what I'm picking up on is, so if you look at the East Pacific and the upper troposphere, models say that the PV inclusion trend is going to decrease, but observations are saying the complete opposite. So similar to what he just said about the MPS, there are many such things. So models say that the highly cell will like decrease its strength.
Yeah.
Observations are saying something else.
Yeah.
So there's this paper by
But if you actually say, how much different observation? Because if I velocity, especially if you in the ocean, I don't think 2,000 accuracy. Because there's no possible. Like, you're right, over India, because you're feeding in the observation. Over the equator, it's related.
So, Lorenzo Polvari and Rich MK. So these two guys had this nice papers way back in 2020. So they said that the diabatic heating in the analysis is not fair. And so,
More like when you look at Reliance rainfall, it's not a good problem.
yeah.
That's a problem, definitely. And that's why India has not that rainfall for comparison. And not that, when you look at the original colony paper of 1990, Chile says, don't be rainfall. Look at fluxes, they are okay, or water okay. Rainfall is not okay.
And so there
Runways is not okay.
and there was just another paper following up Rich MK in 2022, I think, or maybe this year, I think, I can't remember. So those guys said that along with the diabetic heating, what the models are getting consistently wrong is the negative variation. So NAO or something like
Yeah,
that,
yeah.
that's not correct. So these are the reasons why we are seeing sticking trends in the population trend.
Yeah, for example, let's go give it a couple of years back showing that if you look at single person image models, any model will get your decade variant absolutely right. Okay, single model. The single is not wrong comparison. Yeah, single does not make it. No question about it.
Sir, but I find it incredibly confusing that across the board, all models are saying that the Central Pacific or the zonal gradients in the Pacific are 100 degrees.
Yeah.
So how come all models are saying?
Yes, it's actually should be 20 years back. I remember 1994, almost all models got it wrong. Okay, but now they're doing. I don't know if I will focus on that. 10 models saying below normal and combination above normal. Okay, so that is something what has been done in all the models. Okay, so one can only think of one cumulus scheme, nothing else. Okay, now what we should look at, there are many people producing conversion permitting models, like high resolution models. They may be better. Any model use a parameterization is prone to be wrong because you know that for a tip chain, you know that the ratio of converted to study form is not in all the models. Okay. So that is thing will still have improved. And I was hoping by now it will come. Those who do model resolution of 10 kilometers, 1 kilometer, no cumulus scheme should do better. But I'm not in favor of showing that they have been better. What you can look at? Ultimate fact, now that you've got 20 kilometer gain also, I'm sure the next 10 years you get into 5 months of plan everything. Right now, as long as a cumulus scheme, I don't see cumulus scheme high arbitrary. No? There is no real basis for the cumulus scheme. It's the imagination of one man or another man there, best minute. You ask, where is the actual data from that? There was no observation over the ocean. Okay. But there is not even population from India which went to the cumulus scheme. So you can expect cumulus scheme to do well. But what back to the you came out of the change and short. You have very good model, everything looks fine, Monsoon is wrong. Then you found it is something to do with entrainment. They have got some entrainment parameters globally, it's wrong for India. Why? We don't know. So that's another important thing to understand. How, if, for example, during a break, what's happening is dry air from Pakistan coming into India and entrained into the ecosystem dies. Okay? But what tracks have gets to the cloud is very important. We don't have actual observation there. So until those are improved, I had great hope because for 10 to 15 years back, people started doing very high resolution model without cumulative or a small reason. But somehow all that has not been put into the cumulative parameters, not yet come. But that is what is one of the things see. You take the information from Earth body and put it into a cumulative scheme. That is it. That is probably all of them we all know. We are managing because we have no choice. We have no other alternative.
Once these parameters we should get better prediction. Once these parameters are fixed, we should get better prediction.
Yeah, definitely. Yeah, to me, I mean, looking at this in the last 40 years. I can tell you how I was 40 years ago. I used to laugh at this. I was outside. I was not a part of this group. I was in mechanical engineering. There is come and sit here and what? There was a laugh at me. What is you guys about? So from there, you come a long way. There's no question of it. But let me tell you, the progress is not as good as we expected. Given the progress, we thought once you put in the right, they will just keep right thing, everything will get done. So clouds are much more difficult than what we are. And I think we have not done enough experiments with observing with cloud. For example, you want to do really good cumulus scheme, you need the aircraft in real time going through the deep cloud and picking up information about traffic distribution, about whatever problems will be there. If you haven't done it in the US.
So the IPEX experiment has some data from that, but the IIT's IPEX experiment.
Yeah, so there was like 3 months. Say monsoon time, it requires the Air Force pilot to go into monsoon, not, they're not, I don't know why, I think why. My feeling is that the high time they have to got into this. Because a pilot will learn how to go to a cyclone or a deep cloud, he will be a very good pilot. It's a training. And we cannot do it. In America, they do it. Every time you search for American Air Force, well, I'm going to it and get data. So that's a must. Without hardcore data, you will not progress. Only computer, I'm going to tell you, a number of friends in computer science, who thought one computer to fast and faster will solve all problems. Answer is no. Physics has to go in. Computer cannot give the children. What do you do well? So it doesn't happen. People thought, someone told me, forget observation, computer will solve all problems. It's not true. It may be for other problems, but not for the earth. Unfortunately, it's very complicated, but you need every observation to constrain your model. So it could calculate the experiment for about 5 years, but that's a close in thinking. I hope we continue that and do it during the monsoon with a larger aircraft. And although kind, we have got in during the Indo-UK program, of which part of the part, then I and so on. So we need more of that. But we are a country very paranoid because of the long years of foreign rule. We don't want to put this aircraft anywhere near the Himalayas. Then we cannot. So there are very can talk for the bottom. There are all kinds of rules where aircraft can go. To me, that's stupid because the satellite is there. I'm sure there are spy satellites of China, America looking at everything. So but our people are very old fashioned. Nobody will allow that coming here Himalaya. But you will need that in order to make it. But things will change. I'm sure that matter of time we'll have our own aircraft. As a matter of fact, I think we're going to aircraft. So you need to make aircraft go to the cloud. One is to take it. All of us, Joseph Conti did that under what is the experiment 1916. He did an experiment, not like you, famous one, and I don't really old one, and he was offered all instrument banks. So now we can do one, I don't know, the British got, and all the instruments were tied together nicely, and it did have that much of automation. We need both of them. Only the Americans and the British have it. And I hope we do both of them because that. Thank you.